Okay, we are doing a lesson on graphing quadratics without technology, and it looks like I don't have Cami here, which is a bummer. So we're just going to use the annotating here. I'm going to try and use my new pen. Okay, so I'm just going to read this, okay? Stop me if you need to, okay? This week, we'd like you to show evidence that you have learned the following skills. Complete these problems without using Desmos and show your work when appropriate. Okay, so here is the equation. Given the function h of x equals -4 times x minus 1 times x plus 5, provide the following characteristics. Zeros. Okay, so if I were to take this part, this equation right here, let me see if I can make this part right here. And I'm going to write it down over here. Let me choose a different color. Okay, so I'm going to make h of x 0. So we're going to have 0 equals -4 times x minus 1 times x plus 5. And we're going to use this thing called the zero product property. Zero product property. And basically what that means is that if you have two numbers, let's say x and I'm sorry, let's use two different numbers, not x. Okay. Let's do some number, we'll call it a. Whoops, there, I did it. A, and we're going to multiply it by another number, b, and we say that their product equals 0. When we multiply those two numbers and it equals 0, then we say either a must have been 0 or b must have been 0. So for instance, let's just put down two simple numbers. If a was 2 and it was being multiplied by some number and it equaled 0, well, we'd have to know that that number is got to be 0. Okay, so this must be number. So 2 times 0 is 0. So whatever number you put in here, one of these two has to be 0. And so if we took, and this was h of x over here, so now we're going to apply this to our, we're going to apply the zero product property to our function h of x. So we're going to make h of x 0 here. So we're just going to put 0 in place of h of x. And we're going to say -4 times x minus 1 times x plus 5 equals 0. So this, we already know this number. So if we multiply a bunch of numbers together, then this number has to be 0 or this number has to be 0. So x minus 1 must be 0 or x plus 5 must be 0. And we can disregard the -4 right now, because if this is 0, -4 is going to multiply times this and it will be 0. And then 0 will multiply by this and it will be 0. So now I'm just going to split this thing into 2. And I'm going to try and write it in here as best I can. So I'm only going to write x minus 1 and make that equal 0. And then I'm going to put the word or. 0 is going to equal x plus 5. And that's what we had there. It's a little hard to see. Okay, so now I know that this number must be 0 or this number must be 0. So either this thing here is going to equal 0 or this thing here is going to equal 0. And so what I need to do in each situation is I need to solve for x. I'm going to have to rewrite this a little bit. Be patient with me. I'm still learning this new pen. I'm going to take away these parentheses that we used here. Take away these and I'm using that property, that algebraic property called the zero product property. So this is x plus 5. So Justin, what do I need to do here to solve for x over here on the right side? What do I need to do?
Get x by itself.
Okay, what do I need to do to get x by itself?
Subtract 1.
I'm already subtracting 1 here.
Oh, add 1.
Yeah, so down here I'm just going to add 1. And negative 1, it's hard to see that, but it looks like one big 1, but it's negative 1 plus 1. That brings it to 0. And if I add 1 over here, I must add 1 over here. So I'm going to put the 1 on top, so that's 1 plus 0. And so 1 plus 0 would give me x equals 1. And really what we're saying there, see if I can scroll. Bear with me just a second. Okay. And so what we're saying is, let me get my pen back. So we're saying when x minus 1 equals 0, and we substitute 1 because we have x equals 1 here, 1 minus 1, does that equal 0? Yes, it does. It does equal 0. So one of my zeros is x equals 1. Okay, for the sake of erasing, for the sake of clarity here, I just checked my answer. I'm going to erase this. Okay, so one of my zeros is x equals 1. Okay, and I'm going to scroll back up. I got a couple different things I'm doing at the same time so that I can read this better. Okay, so now we're going to find the other 0, and that's right here. 0 equals x plus 5. So what would I have to do to solve this for x?
Subtract 5.
Okay, so that's 0. And then what's 0 minus 5?
0 or negative 5.
Yeah, negative 5. So my other 0 is negative 5. And so I'm going to go over here to the parabola. So my zeros are, I'm going to list them out right here. My x over here was, my first one was 1. And we were setting it equal to h of x, which is 0. So h of x, or the second number in the ordered pair, would be 0. It'd be 0 itself. Okay, so there's the first 0. We're putting an ordered pair notation here. And my second 0 is negative 5. Negative 5. And we set x minus 5 equal to 0. So that's h of x is set to 0. So that's also my second value right there. So those are your two zeros. And so what that means is when we say h of x is 0, well, that's the y-axis right here. That's running. I'm over here on the graph now, and I'm tracing the y-axis. In this case, the y-axis is represented by h of x. So if I were to write that, h of x is the same as saying, that's an x, by the way, is the same as saying the y-axis. Okay, that's the vertical axis. So we're saying that is at 0. So whatever this number is, we got to come down here. This is where h of x equals 0. It's the x-axis. And so what we want to know is, where does this parabola strike the x-axis? Well, it strikes it at, and this one's not really that good. Let me erase that because it's goofy. This parabola, look at the bottom, the number 2. I'm just going to get a picture of it. We can tell where the zeros are of number 2. I'm going to jump to number 2 because I don't have enough room to do this, but you could do it on Desmos as well. We might have to jump over there. Here are the zeros of this parabola. Okay, this is negative 6 and this one's 2. But in yours, you're at 1 and negative 5. Okay. Okay, so now for the sake of room, I'm going to do some erasing here. So zeros are where the parabola intercepts with the x-axis, because the x-axis is where the y is set to 0. Okay, so all along here, is the y-axis, or h of x in this case, is 0. And so those are where the zeros are. That's where this parabola, in this case, is coming through here. So, okay, so now the y-intercept. So I'm going to draw a picture of the Cartesian coordinate plane here really quick. Okay, let's draw a picture of a coordinate plane. Just the best I can here really quick. And now it's asking you to find, for B, the y-intercept. Okay, so let's put our zeros in here first. 1, 0 would be like right there, and -5, 0 would be over there. And then this parabola, so it's a negative. So look at this, it's a negative. So it's, since it's a negative, it's going to be opening downward. So it's going to do something like this. Whoops, not going to do it that crazy. It's totally, it has symmetry, and my drawing does no symmetry at all. So that means it's equal as it comes down. It's going to peak out somewhere over here in the second quadrant, and then it's going to dive. Okay, so when, whoops, look at that. And let me see if I can even fix that. So yeah, it's going to, since it's negative, it's going to open downward. And so it's going to have, that's going to be negative, that's going to be 1, 0. Okay, that's where and this is the h of x axis, and this is the x-axis. And then it's going to be at -5, 0. That's what zeros are. It's at, where's this thing when this axis is at 0, where does it hit? And it hits here at 1 and at -5. And so we went over earlier how to calculate that. But now let's go on to B. Let's go on to B here. Okay, I'm going to erase this and so we can get a little bit better. It's asking now, what is it asking here, Justin? What's it asking for right here?
Oh, the y-intercept.
Yeah, and so I am going to change the color to green. And the y-intercept is there, but I don't know what there is. But I do know that x is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. X is equal to 0 there. So when I'm on the y-axis, x equals 0. X equals 0 on the y-axis. And so now I'm going to go back up here, and every time I see an x, I'm going to substitute for a 0. And so now let me change colors. Now I've got, and maybe I'll do it down here. I'll rewrite h of x. I'll rewrite our function. -4, and I'll try to get all this in. Now I'm not going to write x. I'm going to write 0 minus 1. So I'm checking this and I'm copying it, but I'm putting a 0 in for x right here. Does that make sense? And then I have another x here. Well, since it's the y-intercept, that's on the y-axis, and x equals 0 on the y-axis. That's just the nature of the coordinate plane. So that x is also going to be 0, and that's plus 5. Okay, so now I'm going to use PEMDAS, and you'll probably remember, and I'll write PEMDAS over here. That's the order of operations when we do steps in algebra. Please, let's see, I forgot E. How about that? Oh my goodness. Let me come over here and erase. I forgot E. All right, let's include E and P here. So please excuse my dear Aunt Sally. I hope you remember that. We use that here. And so P stands for parentheses. We do all operations within parentheses first. And so we have addition inside these parentheses, and we have subtraction inside this parentheses. So we do those first. So what's 0 plus 5?
5.
Okay, so we'll do simple arithmetic. What's 0 minus 1?
My -1.
Negative 1. And then we haven't done anything with the negative 4. And then, by the way, we put 0 in each x. So what should this x be?
0.
Yeah, so this is no longer h of x. This is h of 0. Okay, so we're trying to find what h of 0 is. That is h of 0 right there. That's our y-intercept, okay, by definition. So now, my next thing says on the order of operations, I need to do exponents. Do I have any exponents in here?
Anywhere. Oh, no.
Do I have any powers, like 5 to the third power or 5 to the second power? Do you see any of those? No. So we've done parentheses and we check for exponents and there is none. How about multiplication? Do we have any multiplication going on here?
You quite 4.
Okay, so we'll do it from left to right. So negative 4 is the farthest on the left, and then we'll just keep going to the right. What's negative 4 times negative 1?
Negative positive 4.
Yep, that's positive 4. Okay, so we'll write the answer to that. Okay, and we've done this one. So let's just copy the 5. We haven't used the 5 yet. Do we still have multiplication here?
Yeah.
Yeah, we do. What's 4 times 5?
Negative 20.
That's a positive 4 times a positive 5.
Just 20.
Just 20. And now we have h of 0 is equal to 20. That's our answer. So up here, in ordered pair notation, my y-intercept, the x is 0, because 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All up and down, x is 0. So this is my x in my ordered pair, x comma y. And what's my y over here? I got it right here.
20.
Yeah, so my ordered pair is 0, comma 20. Does that seem right? Positive 20 up here? Does that seem right to you?
Yeah.
Okay. Yeah, so your picture has to fit. Your answer has to fit the picture. So up here you're going to put 0, comma 20. Okay. And now we're going to do, get off my pen here. We're going to do letter C right here. Does this open up or down?
Letter C.
Does this open up or down? We drew a picture of it, but it opens down, and that's because the number that's in the front here is a negative, and that leading value, that's the number that leads in front of these other values. So negative 4 is called the leading coefficient or the leading number. It's a negative number, so therefore it doesn't open up. Negative is a down number. It's a direction of down. Negative is a downward direction. So it opens down. Okay? All right, I hope that helps. We are out of time. So I'm going to